Okay, now let me show you how we can move on and create 3D models. So here's the process, the workflow. In Trimble RealWorks, we select the area that we want to model. We segment out a section of that, and then we select the geometry type we want to create. So a couple of geometry types that I'm going to create for you today. One is a beam. I'm going to then, once I've created one beam, I can then duplicate it in multiple locations. I'll show you how to create that duplication. Then I'll show you how we can automatically model a pipe, and then also the core of the building. So it starts to build up a three-dimensional model. If one doesn't exist, then you'll be able to then export that into your BIM. So let's go into Trimble RealWorks now, and I'll open up a different file. So it takes a little few moments to load in the points. You'll notice down in the right-hand corner of the software, we can determine how many points we want to see at a time, and you can see that it's dynamically loading the points. And while it's dynamically loading, I can actually rotate the 3D point cloud around and start using the 3D point cloud as it's dynamically loading the number of points. Now I segmented out a section and added some additional detail, and I'm going to show you that particular part of the building. So that's in this area, and I'll change the visualization for you. And see here, see it in a grayscale visualization. It makes it much easier for you to see the 3D point cloud. You can see there's lots of activity going on in this building site. People walking around. You can see hangers down. You can see a scissor lift over here. You can see the stairs being built down to the next floor, part of the next floor. So lots of different pieces of data here. So what I might do is model this this support beam support column for you. It's a steel support column. So what I'm going to do is make sure that I'm in the modeling mode. And what I'm going to do is define where this this column is. So if I look here from the top view, I can see that here's a column right here. There's also another one over here. So I'm going to model one and then duplicate it in the other location. So in the modeling tool, I'm going to select, in this case, SteelWorks Creator tool. And you notice that I can actually import a catalog of different types of steel types. The way I can import that is I can import my SteelWorks catalog. There's a couple of catalogs that come with Trimble RealWorks. They're based in the location where the software is loaded. Trimble RealWorks, you can see that there's some tables, SteelWorks, and you have two different types that I can import. So I'll import both of them just to show you how it's done. So the AISC and the DIN configurations. Now once they're imported in, I have them in the drop-down menu here, and then you can see the different types of tables of types that you have available to you as well. Okay, and then you'll have different size beams and so forth. In this particular case, I'm just going to use no table, mostly because I'm not a steel expert and I won't be able to pick the right one, so I won't get any criticisms that way. So what I'm going to do with this SteelWorks Creator tool is I'm going to segment out where the first support column is, and then I'm going to model it. Okay, so you can see here, it's segmented out the column. I'm going to lock it in a 2D view. So you can see the point cloud representing the column. You don't necessarily get all of it, depending on how much of it is scanned. I'm going to lock it in 2D. And then I can select the type of beam here. So you see a H section, an I section, a U section, L section, and a T section. So I'm going to pick, for this one, I'm going to pick a H section. And what I can do is simply start with the top left-hand corner in this case. And you can see that it's going to fit this type of beam to the point where the point cloud is. And once I validate, that's this check mark here, you can see that it automatically fits it to the point cloud. Okay, so there you have a steel beam. So I'm going to hit create. You can notice that you can actually type in the length if you want. I'm going to hit create. Now you can see my steel beam in the 3D point cloud. Very good. So now I have, instead of doing that for every single beam, now that I have there's many of the same type in here. Let's duplicate that rather than having to create that all over again. So if I change my visualization back to the grayscaling, we're able to see that the other beam is located, same support beam or column is located over here. So I'm going to duplicate this one to that location. So I'm going to select my duplicator tool under modeling, duplicator tool. And I'm going to pick along a line. In this case, I have a defined orientation system. And I'm going to pick that 3D direction. And I think if I pick my x-axis, you can see the lines with the layout of this specific building. So I can validate that direction. And now you can see that it starts to duplicate the column for me. In this case, I have it set to 3 in quantity. I'm going to change it to 1 in this case. Hit tab, you can see the 1. Now I can type in a distance, I can pick the location, or I can simply slide it to the location itself. So I can grab this beam, and you can see where the support beam is here, or the support column. I can slide it into place right over where it's located. Right here. And what I can do is I can double check this by rotating around. Hopefully I'm getting slow enough there for you. You can see that I can also fit dynamically in 3D the location from this direction as well. So once I'm happy with the location of that, I just hit create. And if I close, you can see that I now have 2 support columns, steel beam support columns, created within my 3D point cloud. So that's how you can create beams quickly and simply within Trimble RealWorks and start creating our 3D model. Now, of course, we're going to have multitude number across the whole floor of this building, and we can duplicate it multiple number of times. We can also adjust it if the height doesn't fit correctly. So here you can see it's slightly poking out of the ceiling. We can actually select that beam if we want to. And we can use our geometry modifier tool, and we can adjust the height of that beam if we want. So we would actually go into the 3D point cloud there and make sure that it fits exactly where we want it to fit. Like so. And close. Okay, so that's how you can model some steelworks within Trimble RealWorks. You can see the process is relatively straightforward. So next I'm going to find a piece of point cloud to be able to model a pipe for you. So I'm going to go to my Scan Explorer tool. And this gives me a great 2.5D type of view of the 3D point cloud, and it's much easier for me to navigate throughout that point cloud. I can select a station that I want to go to. Like so. Okay, so I think it was back here. Yep, so here we have a pipe coming up through the floor and going up through to the ceiling. You have another one running along over here. And down the other side, you can see a worker on site doing some layout on the side as well. So what I'm going to do is extract some points in detail of that specific area so that I can model these pipes. So in my Scan Explorer tool, I'm going to use the Extract Points function. I'm going to select off the screen here the area that I want to load in detailed points for. Oops. Okay, I select a sampling of the points that I want. I hit Create, and you can see down in the right-hand corner the extraction of the points. You can see that I selected 110,000 points just to represent that area. You notice that we can export directly in various different formats to be able to extract to other software if you want to as well. So now if I go back to Trimble RealWorks, you'll see that this section of data has been extracted over here. So I'm going to turn off my other data sets and also hide my geometry from before. And I'm going to focus on just this area. I'm going to center my rotation so that you can see the 3D point cloud. So what we might do is we might edit out a little bit of data here where we have a chance. I'm going to use my segmentation tool and use the white cloud. I'm going to segment out a little bit of data here. Just because it's in the way. Makes it a little bit easier. Okay, so we use this data set. And now what I'm going to do is, let me change back visualization so it's much easier for you to see. Let's go ahead and model this pipe first. So to automatically model a pipe, we can use our Easy Pipe tool. So that's under Plant. Well, we have to select the point cloud first. Go to Plant, Easy Pipe tool. Now the first step in extracting a pipe is you hit the Extract button, you click on the point cloud where the pipe is. The software will automatically know that you're trying to create a cylinder and extracts from the point cloud the radius of the cylinder and the diameter of the cylinder, and we can now begin and ask it to track along the point cloud and automatically extract the rest of the pipe. So what I can do is hit the Start button, and you see that it automatically runs along the point cloud and starts extracting the pipe for me. Okay, you'll notice that down here at the bottom of the floor, it tries to track the point cloud, so it doesn't quite get it like we want. So what we can do is we can delete that segment. So we can delete element. So we have a nice point cloud now. So now what we want to do is smooth the elements. You'll notice that it's made up of right now lots of different pieces. So we're going to smooth it, and then we're going to model it. So now we have a nice smooth model, and we create it. And what we can do is this piece, we know it goes to the floor, we can adjust it by using our modifier tool. You can see that we can make it hit the ground. Okay, so there we have one pipe. So we have the Easy Pipe tool open. Let's extract this other pipe that runs all the way across here. So what we're going to do is hit extract, hit where the point cloud is, and we're going to ask it to extract it along the point cloud. You can see it tracked all the way down to this end and even went around the bend, the crazy bend in the pipe right here. All the way around. And at the other end, it ran into a bit of trouble. So what we can do is we can intervene in that. We can delete this last element, and then we can ask it to continue. So we're going to pick to continue. There we go. So it was able to finish off. Sometimes when there's a gap in the point cloud, the automated tool can get a bit lost, so we can intervene a little bit and help it along its way. All right, so now we just hit smooth and model. Now we should have a nice model pipe here. So you can see the bend in the pipe. I'm going to rotate this around. You can see that it bends, changes direction, and then changes direction up. And likewise at this end, it's not a straight line. There's dynamic changes in the point cloud there. And we create. Okay, so now we've modeled our piping. So you can see that we've done now a beam and a pipe. So let's look if we can model the core of the building as well. Okay, let me just hide that for a moment. So now you can see it's loading the points. I've had my setting to 100 million. I think in this project cloud thus far that we've added to it is 29 million. But obviously we can get to many, many more. So let's look see how we can model the core here. See if I can make this happen. So we're going to look at this, either one of these elevator cores. Okay, we select the point cloud. We're going to use cloud-based modeling. Okay, you can see it's dynamically loading the points back in again now. We're going to segment out the area that we want. I'm going to segment out this area. Keep that in. I'll change it to white visualization. Let's rotate it around. Center it. Take out a few points here. Okay, I'm going to go to the top view. And what I can do is I can trace out the core of the building here. Now, if we had more detail of the actual interior part of the wall, we could actually trace out the interior and exterior all in one and extract it. But I'll show you the process here whereby we'll just do one side of the wall. So it's easy for me to just trace this out like so. Or what I can do is, if I escape, I can choose this rectangular drawing tool. And I can select the line so you can see the green line representing the position of the wall. And then, so you see basically it creates a cross-section. This is in our extrusion tool within the 3D cloud-based modeler. And I'll ask it to fit it to the point cloud. So it's what the warning here is telling me that it hasn't finished loading in all the points. Do you want me to wait for that to model? Or do you want me just to model what I have right now? So I'll just say stop, and you can see how it models the core. And then I hit create. And you can see that the core is starting to be modeled. So you can see from the 3D modeling that I've been able to show you how to model some beams or support structure. I've also been able to model a pipe, and then we started modeling the core of the lift well on top of that as well. So you can see how you can start to build up your 3D elements, and what we can do is select those 3D elements, and we can export them out like I showed you before. We can export them out in different formats so that you can bring it into your BIM. So something like Vico software, which will allow you to then start doing your 3D and 4D management of your building.